Hi, welcome to area and volume, surface area and volume of different shapes. Alright? And I want to tell you that in volume, it's about space. Alright? Space. How big it is. How much space does it occupy? Whereas area is just the external, the one that wraps up how much of that space that's the external area. As we go along into more sums, you would see the meaning and you would see its implications in everyday life. Alright, first of all, I'd like you to have your handphone on a silent mode. Right, okay, good. And feel charged, okay? Feel good and feel happy to do this sum. Now, it's really what we're taking here. We're taking a real traditional approach in writing in chalk, explaining you, bringing you through the sums, the process, the methods, so that you would have a better understanding. And if you're not very clear about it, rewind your tape and get back to it so that you're following and you're in tune. I can guarantee you, with the sums, the varied sums that you're taking, the various shapes, you would become really an expert in this chapter called area and volume. Alright? Now let's look at this. What is this sum all about? It's a solid metal prism of length 0.35 meters and has a regular hexagonal cross-section at its ends as shown in the figure. Well, the figure is here. You can see a regular hexagon, alright? And a hexagon has got 6 sides and the length is 0.35 meters. Given that the cross-sectional area is approximately 93.5 cm squared, show that the sides of the hexagon is 6 cm. Now, be careful about the units of measurement. This is in meter and this is in cm. So if I were to change it to cm, this will be none other than, if I look at it, it will be changed, it will be 35 cm. So the length is 35 cm. I could change this way, 35 cm, clearer then. Okay, now from there, we need to show what is its side. We have to show that it's 6. And then what happens to this prism? It's melted down and it's recast into a cone. The base area of the cone is twice the cross-sectional area of the hexagonal prism. Well, this cross-sectional hexagon prism, the area here is given to be 93.5 cm squared. So, well, this cone has got a base area which is twice, so that will be, you multiply it by 2. You're asked to find the height of the cone. Now, if the melted prism was recast into a sphere, what is the radius? Okay, so you see we're covering from a prism which is hexagonal, moving to a cone, and then from this aspect we're talking about a sphere, and the next part of it, if the spherical crystal ball had the same surface area as the hexagonal prism, find the radius of the crystal sphere. Alright, you want to find out. So let me write down the crystal sphere so that you know what we are talking about. Okay, it's very encompassing. There's a lot to cover and a lot to learn. Now let's look at the first sum here. We've got to find out what are the length. And if I were to draw and join them all up, you will see that a hexagon is made of none other than 6 triangles. 6 triangles, right? And each triangle, this will be, you are going to divide it by 6 because this is the area of each triangle. The total area is 93.5. So it'll be equally divided. So what we're going to do is going to find the length. Now if you look at a hexagon, let's look at it. What is the interior angle of a hexagon? What is the formula? It is actually interior angle, let me write here, is n minus 2 times 180 degrees divided by the number of sides, n. If you have 6 sides is 6 minus 2, all right, times 180 divided by 6. So if you look at it, 6 minus 2 divided by 6 times 180, you could cancel this, you get 4 times 30 degrees is 120 degrees. Or you could do by exterior angle. What is the exterior angle? The sum of exterior angles is always 360. 360 divided by 6, what do you get? 360, the exterior angle, will be 360 divided by 6 will be 60 degrees. And the exterior and the interior add up to 180 degrees, right? It's angles on a straight line. Ooh. So, well, this is 60. You can see interior will be 180 minus 60. You get 120. It's just a quick revision on angle property. Now, why do I need that? If this is 120, you divide it by 2. This will be 60 degrees. This will be 60 degrees. And this will be 60. You can see that it is an equilateral triangle. Alright? Equilateral triangle. And my dear friends, what about an equilateral triangle? If you look at the sides, if this is A, alright? And you know that the area of a triangle is equals to half AB, yes, sine C. Beautiful, the formula. Good. Rather than base times height, divide by 2. You can use the other formula. In this case, the A and the B are both the same. The sine C, the C is a 60 degrees. So you need to know all this. And the area of the triangle is none other than 93.6.5, I'm afraid they're given. Yep. Divided by 6, that's the area of one triangle because the whole hexagon is 93.5. Now that area equals to half A times A squared, sine 60 degrees. Now, I'd like you to have this very important. Without calculator, how do we get sine 60? Alright, I'd like to tell you about this important information. Good for you to know. If I have an equilateral triangle and I put it as 2, 2, 2, I cut it into 2 equal parts, 1, 1. This side will be a root 3. This is 60 degrees. Do you see it? This will be 30 degrees here. So your sine 60 is root 3 over 2. You can see it very clearly. So you've got a 93.5 upon 6 equals to half A squared times sine 60 degrees, root 3 over 2. You're going to work out what is A. Bring out this over there, 93.5 times 4 over 6. Root 3 will come down, right? So you've got all that going. Divide becomes times, times becomes divide. Find the square root of it at the end of it, and you've got your A. Put it into your calculator, all right, and work that out. All right, can we do that, please? 93.5 times 4, answer, divided by 6. Be careful of using a calculator because you know the calculator, I would always say, is a gundu organ. Wow, you get your A to be, this whole thing is 35.988. That's about 36. And a square root of 36 will clearly tell you that it is 6 cm, which we have shown. All right? Okay, that answers question part A. The next part of the sum is that this prism is melted to form a cone. Now the base area of the cone is twice. So let's work on it. I would like you to work while I clean the board and we'll look into the sum. It's really beautiful volume. Alright? Getting to know the shapes and understanding. When you melt a cone, when you melt the prism, that volume of what you get, the volume of the hexagonal prism, alright? And you take that cone, the volume of that prism, and you change it into the cone. And those two volumes are the same. All right, take note of that. So having that inside knowledge, we're now going to apply on that. Well, I've got a lovely board for you. Right, now let's look at the sum again. Now this whole cone, melt, you get, all right, liquidified, and we now mold it into a cone. And this cone that we have is twice, all right, the area of this is twice. I'm doing B. The area of this is twice that of the hexagonal prism. And what was the area of the hexagonal prism? 93.5 cm squared. So what does this area now becomes? It is 93.5 times 2. You get 10, 6 plus 1, 7, 2 times 9, 18. That's the area of this cross-sectional area. Now, we got to know, well, this is the radius. That's the height of the cone. And what is the volume of the cone? What shape is it? It's a pyramid. It's pointed, a pyramid. All right? A pyramid means come to the point. So the volume of the pyramid is equal to pi r squared h over 3. Remember, a pyramid is always the area of the base times the height divided by 3 because it's pointed. A pyramid has got a point, cut, it comes to a dot. All right, that's a pyramid. Unlike the earlier shape, which was a prism, there is a cross-sectional area. You cut, you get to that other side, which is the same. And so in the case of a prism, the volume will be the area of the cross-section times the height. All right, unlike a pyramid, which is you're going to divide it by 3 because it's shrunk. So my dear friends, well, you've got the area of cross-section. So what is this volume? The volume is the same as that of the prism. So what was the volume of the prism? Can you tell me the volume of hexagonal prism? Yes, you've got the area of the cross-section, all right, times the height. And the cross-section is 93.5 times the height. And the height here was 35 cm. All right, please take note. Do not be careless and put at 0.35. So when you multiply that, would you get that for me, please? 93.5 times 35. We've got 3272.5 cm cube. All right, I better wear my glasses to see if I'm seeing the decimal point right. Now always be careful, avoid careless mistakes. Ooh la la, yeah. So it's 3272.5 cm cube. Units must be written. And this prism has the same volume. This cone has the same prism as the hexagonal prism. The prism and the pyramid. They both have the same volume because all that is melted is changed into this cone, the pyramid. So what do we write from there? We said, hey, all right, volume of the cone will be, what's the volume of the cone? 3272.5 cm cube. And we have the cross-sectional area, which is the area times the height divided by 3. And we need to solve that. So we know that the cross-sectional area is 187 times the height divided by 3 is 3272.5. So what is h going to be? We're going to bring the 3 over, and then you're going to divide it by 187. So that calls for calculator again. You're going to multiply by 3 and get the answer, divide by 187. Yes, a very neat answer. The height is 52.5 cm. That's the height of the cone. Alright, so we said A, you're 52.5 cm. That's the height of the cone. Got it? Now the next part of it is said that this, if the melted prism was recast into a sphere, find its radius. Alright, if it's recast into a sphere, find the radius. Okay, now let's look at part C. Nothing to fear. Well, now the whole thing, the cone, the prism, the hexagonal prism, which is this volume, the same as a cone because they're used. So now this, instead of becoming a cone, has become a sphere. So what is the volume of a sphere? Yep. Please do not get confused between its surface area. The volume of a sphere is none other than 4/3 pi r cubed. You got it. Great. So put it in, and this is the answer. 3272.5 equals to 4/3 pi r cubed. Make r the leader. So you've got, all you need to do is to just manipulate the formula. Multiply by 3, divide by 4 pi, get the answer, and then you find the cube root of this whole thing. Bring the 3 over, divide by 4 pi, and then find the cube root. Alright, be very cautious when you get that going. Alright, because you got a cube root there. Alright, 3272.5 multiplied by 3. Alright, get answer divided bracket 4 times pi. Well, look at pi. Yes, pi is here. Close bracket. Answer, you've got 781.25. Yep, let me write that. So you got a cube root of 781.25. And what will that answer be? The cube root of it. You get a 9.2. Alright? So 9.21. Your radius will be 9.21 cm. That will be the proximate radius. Okay? So if you change this whole thing, alright, into a ball, a sphere, that radius of the sphere will be 9.21. That ball, that sphere, will have the same volume as this, given the condition, because the melted prism is recast into a sphere. Now let's look at question D. If a spherical crystal ball had the same surface area as this hexagonal prism, what is that radius? Now that's a totally different sum. I gave you this sum because I wanted you to see the fine distinction. Well, in this case, for C, they both had the same volume, right? Because it's melted and it's recast. So it's the same amount of matter used. Whereas in the second one, there is a crystal ball. And that surface area of the crystal ball is the same as this surface area of this prism. Same area. So we need to equate area with area, alright? So let's look at that. That's the fine distinction between this. So how do we go about that? I'm going to take this, squeeze this space in, and I need you to pay attention. If you look at D, alright, in D, the surface area of the sphere will be equal to the total surface area of the prism. This hexagonal prism, alright, hexagonal prism. And what is the total surface area of the hexagonal prism? Well, we'll look at this. This is 93.5. 93.5 is multiplied by 2, yeah, because you're given. And we've got how many rectangles? 6 rectangles. And each this is 6, and this is 35. So the area of one rectangle will be 6 times 35. You're going to add to this plus 6 times 35. And how many of that? 6 of it. 6 rectangles. So it's pretty easy. Whereas for the area of the sphere is 4 pi r squared. Alright, surface area. Area pi r squared, 4 pi r squared. Whereas full volume of sphere is 4/3 pi r cubed. Please, alright, don't tell me I can't remember. You've got a young, fresh brain, not one of an old person. Even an elderly, alright, maybe double my age. Well, also, if you know your maths, you know it, you can't forget it. Alright, so take note of that, please. So this total surface, the surface area of a sphere, the external area, is equal to the surface area of this. All you need to do is to do some simple calculation. Alright, what do we get? We've got 93.5 times 2. What do we get earlier on? We get 187, right? Plus, look at this, 6 times 35 times 6. So that 6 times 6 is 36 times 35. And we've got 1260. Add it with 187. You plus 187 and you get 1447. Now my dear, let's take the space here. The 4 pi r squared is equal to 1447 cm squared, area to area. The radius is going to be 1447 divided by 4 pi, and you're going to find the square root. So you're going to divide it. Remember to put your bracket when you divide. 4 times pi, close bracket. You've got 115 here, and the square root of 115, and then you find the square root of it. Ooh la la, I have to find the square root, and I've got a 10.7. 10.73, but I shall put the 3 significant figures. That's what we get. Now one more time, let me check that answer again. All right, I get 1447, right, divided by 4 pi times pi. Get the answer, find the square root of it, and we've got 10.73. 10.7 as 3SF figure. Now that's the radius of the crystal sphere. Now it is pretty interesting and easy. Alright, and let me tell you, my dear friends, volume is one of the favorite sums to get marks, good marks. Alright, do not get intimidated by the length of the sum and say, I want to run away. No, it's easy. Nothing, remembering formulas is not difficult. If it's a prism, it's an area of cross-section times the height. So if we found this, we know this area that's given, multiplied by the height, that gave us the volume of this figure. Once we've got the volume of this figure, very easily we could find out, alright, we can move on. The volume of this equals the volume of this cone, and this is a pyramid. A pyramid is pointed at one end, pi r squared h over 3. So very easily you equate them. The volume of the hexagonal prism, alright, you got that? And equals the volume of the cone. Well, you put it in, you know the area of the base. You've got that, and all you need to do is the height. Alright, it's just a manipulation of the formula, and that's the height of the cone. Alright, height of the cone. Now as for the sphere, if it's melted and formed the sphere, the volume of this formula, the formula 4/3 pi r cubed, is equals the volume of the hexagon. And all you need to do is to again find out r. Make r the leader, multiply by 3, divide by 4 pi, cube root of it, and you say, woo, you look at it, the radius is 9.2. Now the fourth sum, there is a little bit of a difference. What's the difference? It's the surface area that's the same. Whereas here, it's the volume is the same. The volume of the sphere is the same as the volume of the prism, whereas here, the surface area of the sphere is the same as the surface area of the prism. So we equate it with this beautiful formula, alright, surface area 4 pi r squared equals the area of the hexagonal prism. And when you get that, very easily, remember 6 rectangles plus the 2 hexagons. And the hexagons have already been given to you, 93.5. So with that, we can find the radius, right? Stay on for the next sum.